Hey, good evening, everyone. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right, great. So, guys, we are waiting for a few more minutes, right? We are expecting more candidates to join in, right? So let's wait for 5 more minutes and then we'll begin with our session. Hi, once again, good evening, everyone, and welcome back to your sessions. Right. I hope my voice is clearly audible. You can simply raise your hands to confirm this. All right, great. So, guys, in today's session, we are going to discuss about the topic moments. Right. It is one of the most important topics in statistics. All right. Okay. Good evening, guys. Good evening. And all right, so let's begin with today's session, right? And the topic that we are going to discuss is moments, right? Moments is basically it falls into the descriptive statistics, right? Before discussing moments, let me give you this idea about what are the major parts in statistics, right? And how you can differentiate, right? So statistics majorly has four parts, or let's say it's divided into four broad categories, right? The first part is the descriptive statistics, right? And in this descriptive statistics, we basically get the overview of the data, right? A general overview. There are a lot of things that falls into this part of statistics, right? Where you get to know about data and its individual columns, right? There are various parameters on which descriptive statistics work, right? So we'll be discussing about this. So basically, just to give you this idea, right? Here in descriptive statistics, we have topics like, let's say, percentage, right? Then we have percentiles. Then we have, let's say, quartiles, right? Then we have the central tendency, which is mean, median, and mode, right? Moving ahead with this, since we have quartiles, which is why we'll also have interquartile range, right? Then we have topics like the normalization part, right? Which is technically termed as the z-score, right? And moving ahead with this, we have, uh, let's say, right? So moving ahead with this, we have variance, right? We have standard deviation, right? Moving on, we have skewness, kurtosis, etc. All right. Now, talking about the second part of statistics, right? The second part of statistics is majorly the inferential statistics, right? And in inferential statistics, we majorly deal with more than one column, try to understand the behavior of one column with respect to the other, right? How it changes, etc., etc. So the part of the topics that fall into this window is we have covariance, right? We have correlation. We have various types of hypothesis testing, right? There are various types of hypothesis testing. You'll learn this in advanced statistics in machine learning journey, right? You'll learn this topic in the coming times when you're in during your machine learning days, right? So inferential statistics, just to give you this overview, it's majorly about understanding the relationships between features, right? Moving on, we have the third part here, which is predictive analytics. right? Predictive analytics. This is where we make predictions. Right? We make predictions, and this is nothing but this is your complete machine learning. All right. And moving on with the final part, we have the fourth part, which is prescriptive statistics. Right? So based on all the above three statistics that you have analyzed your data, right? You can here prescribe, or you can say you can make suggestions that will help in making business decisions, right? So here you can broadly classify the complete statistics into these four parts, right? First is the descriptive statistics, where you get to know about the overview of the data that you're dealing with, right? The second is the inferential statistics. This in inferential statistics, we try to understand the relationship between the features. Moving ahead with the predictive analytics, where we make prediction of a target variable, right? And this is your complete machine learning. And finally, we have the prescriptive statistics that deals with making suggestions or prescribing something or some valuable information, right, from the data that will help you to make good business decisions, right? You are, let's say, the stakeholders. All right. So here, up till now, we have been discussing. Right. So up till now, we have been discussing about the descriptive statistics, right? We have discussed about percentage, percentiles, quartiles, mean, median, mode, right? We have discussed about IQR, right? We have discussed about Z-score, which is min-max normalization, right? This is basically the normalization part that we have discussed. Although uh, these two topics will be discussed more in detail in your machine learning days again, right? And in today's session, we are going to discuss about the four moments, right? And these four moments also fall into the category of descriptive statistics, which is mean is your first moment, variance is your second moment, skewness is your third moment, and kurtosis is the fourth moment, right? So these are the four moments we are going to discuss in today's session. You have to understand what exactly these terms are and what they represent from the data, right? So in statistics, basically, you can quantify everything, which means you can simply represent each and everything into a form of a number, right? So that a mathematical comparison can be done. All right. So it's statistics is about, let's say, quantification, right? We will simply quantify or will represent every relation or everything that is possible in the form of a number, right? And this quantification process will help us to understand everything with mathematical perspective. All right. So here, let's begin with our topic for the day, right? And the topic for the day is moments, right? As mentioned, we have four moments. First is mean, right? We have the first moment, which is mean of the data. Then we have second moment. Second moment is called the variance of the data, right? Then we have the third moment. Third moment is the skewness, right? And then we have the fourth moment, which is, of course, kurtosis, right? So these three are very widely used or extensively used in the field of machine learning. Although fourth moment is hardly of any importance, but yes, since it exists, right? Which is why we'll discuss the fourth moment as well, right? So just to give you an overview, mean basically represents the average value, right? Like how mean represents an average value, in the similar way, the variance basically represents the spread of the data, right? It will tell you about the spread of data, how widely your data is spread. This will give you a quantified number for it, right? Now, talking about the third statistics or third moment majorly indicates majorly indicates the amount of biasness the data has, right? So it's, you can say it's the measure of biasedness, right? Biasness, or we also call this as tiltedness, right? And finally, we have the fourth moment, which is the measure of peakedness, right? So peak is basically, it's the peak in raw terms is a kind of a summit, right? Peak basically means summit, right? Which is nothing but the highest point of something, right? Highest point of something, which is why it tells you about how high or low the data is, right? Or the peak of the data is. At the same time, if we talk about biasness, bias is basically, it's a kind of favoritism, right? If you look for this particular word's meaning, right? Morphologically, this means, right? So morphologically, this basically means some kind of favoritism, right? Some kind of favoritism. And skewness is exactly the measure of this favoritism, right? And favoritism with respect to what? We will discuss this when we'll discuss this particular topic for the day. All right. So moving ahead with this, let's move ahead and discuss about the first topic in detail, which is the mean of the data stands at the first moment. Right. Mean, as already stated, it gives you the average value, right? And you can, once you have the average value, right, of the data, you can easily conclude, or you can use this, let's say, average value as per your need, right? So for example, let's say if you're discussing about the employee data set, and you already know the average salary of an employee in any organization, right? Then you can basically you can make predictions on how, let's say, if you are applying for the position in this organization, you can let's say you can get an idea about how much salary will the company offer based on the average salary of the employees, right? Or if it is in specific department, you can find the average salary in a specific department, and then you'll get this idea how much company is ready to pay as a compensation for your services, right? So this is exactly how average value is used, right? And here, there's a mathematical formula, of course, and all the moments, needless to say, these are described only for continuous data, right? This is only for continuous data. It cannot be calculated on categorical data. I hope everyone is able to relate now why it cannot be calculated for a categorical data, right? You can simply raise your hands if you can relate how mean cannot be calculated on categorical data, right? Because we have discussed this part in our previous sessions. All right, great. Right. So just to give you this idea, let's say if we want to take an example here, right? So example could be taken based on, let's say I have 3 data points, maybe, the height of the attendees, right? So let's say, let's take any 3 heights just for an example. Let's say 165 centimeters, 150 centimeters, and 185 centimeters. Right. Now, if you want to find what is the average height here, right? This is the data of heights. All right. Now here, if you want to get an idea, what will be the average height? So how do we calculate that? We simply add all of these three terms together, 165 plus 150 plus 185, right? And divided by the total number of elements. So this is 1, 2, and 3. 3 elements will divide it by 3, right? So this will give us the average value or average height, right? And if you, let's say, calculate this, it's 5 and 5, 10, right? 1 caret, and let's say 6 and 6, 12, and 8, 20, 0, 2, and this is 500, right? By 3, right? You can divide this by 3. So this is 5. Okay, I'll write this here. So this is 1 times, 6 times, and 6 times 0.6, right? So this will be the average height. Right? This is the average height here that you get. All right. Now, if I want to, let's say, generalize this formula, right? What exactly I've done here, if I want to generalize this part, right? So what could be done is I can write a formula for this, right? And formula in mathematics is written. There are a few things that you need to understand. If you're adding something like this, right, it is basically represented as summation using the sigma sign, right? This stands for summation, which means you're going to add a few things, right? And if you're going to multiply, it's represented as the symbol of pi, right? This is the product function if you want to multiply this. So we can say product, right? So product is more technical term than multiplication, right? So if I want to represent this, so what could be done is I can simply write it, right? So I can simply write it. Let's say this 165 is the first term. So I'll take any random let's say alphabet for the representation. For example, let's say I select X, right? So this will be X1, right? This will be X2, and this will be X3, right? So this is X1 plus X2 plus X3, right? So if I want to represent this like this, it is nothing but the sum of numbers. So X1 plus X2 plus X3, like this, divided by 3, right? So if it goes, let's say if you have 5 elements, for example, right? If you have 5 elements, so what this will happen is it will, 2 more elements will be added here, right? And while, let's say if you want the actual output, you just replace these X1, X2, and so on with their respective values, right? So this will be divided by 5 now. All right. So as we can see, the total number of elements that we have, their actual values will be present here, and the count of the value will be present in the denominator. So what could be done is, let's say, since the total number of elements is not fixed, right? It could vary based on data to data. All right. So what I'll do is I'll simply represent this with xi, right? Where I will simply take their respective values. For example, let's say if I want x1, I'll replace this I with 1. If I want x2, I can replace this I with 2, and so on, right? So here, how it is represented is, and since these plus signs will be represented using the summation, right? So what we'll do is we'll simply write xi, right? And we'll add all the xi's together. And here we'll mention that I will start from 1. So I is equals to 1, and it will go up till n. So let's say here, for this case, n is 5. N is nothing but the total number of elements, right? And we'll divide this by the total number of elements itself, right? So this is the formula for mean, and it is represented using the symbol of mu, right? So this is the mathematical formula for mean of the data, right? And this mean basically gives you the average value. All right, so this is how mean can be understood. right? So you can simply raise your hands if you're able to follow up till here. We are not taking I is equals to I. This is 1 here, right? This is 1. This is not I equals to I. Please focus on the session, right? This is not I. This is 1. This is 1. Right? So I basically means we are representing these values with I, right? These values 1, 2, 3, 4. All xi is here. X1, x2, x3. These are represented with a common letter here, right? So that we can generalize this, right? We are representing this as xi. If you expand this, this will be expanded like this only for n equals to 5. Right. So guys, just give me a moment. I think something went wrong. Just give me a moment, right? Right. So okay, one of you is asking in the summation means what? This is the total number of elements. N is total number of elements. For example, when n is equals to 5, the formula will be expanded like this. And now you can replace these values with actual numbers of the data. Right. So this is how mean can be understood. And this is one of the simplest topics in statistics, right? Mean is something you have been studying from your school days. All right. So all right. Now, moving on. Let's say if you want to take an example, we can take an example here, right? And the example could be, let's say I have a few numbers of which, let's say the data that I'm working on, right? Let's take some random numbers, right? So let's take maybe a 12, 14, maybe another 14, then we'll take 17 and 18, right? 5 numbers. If you want to calculate the mean of this data, right, you can easily add up all these numbers. So this will be, let's say, we'll use the formula for mean, and this is the formula, right? Summation of xi by n. You can expand this formula since n is equals to 5 here, right? N is equals to 5, right? So what will happen here is we'll add up all these numbers together, right? And divide it by the total number of elements, which is 5, right? So this is nothing but 75 by 5, which is 15, right? So this is 75 by 5, which is 15, right? So the mean of this data is 15. And always remember, the mean of the data will always lie between the minimum and the maximum value, right? I think this is needless to say, because this is very, it's a very, let's say, something that just is not required for a mention, because average value will always lie between minimum and maximum values. All right. Now, moving on, discussing about the second moment here, right? And second moment, right? Second moment is nothing but variance, right? Variance here is basically the measure of spread. How widely your data is spread is the basically variance, right? So for example, let's say if we take the same example, right? We had 12, let me see the example quickly, right? So this is 12, 14, right? So this is 14, another 14, followed by a 17 and an 18, right? Same data here. Now, if you look at this second moment, right, which is variance, the formula for variance, it's represented using VAR, right? And the formula here is summation of xi, where again, I will go from 1 to n divided by total number of elements, right? This is the formula for me. If you take the square of every value before adding them, it becomes the formula for variance. All right. So you can do this calculation at your end. Let's say if you want to, expand this, your variance will be expanded as x1 square plus x2 square plus x3 square plus x4 square plus x5 square. Since we have 5 elements, hence n becomes 5, right? And if you keep on putting a value and expand this formula will be expanded up to this, right? Now you can input the actual values here. X1 here is 12. So this is the square of 12. X2 here is 14, which is the second element, right? So this is the square of 14, followed by x3 square. X3 is again 14. So we'll take the square of 14, right? X4 is 17 here. We'll take the square of 17. And x5 is 18 here. So we'll take the square of 18, right? We can divide this by the total number of elements. Right. And once you do the calculations here, right? Let me quickly do that. All right. So if we start with the square of 12 is 144, right? Square of 14 is 196 plus 196, right? Then the square of 17 is 289, right? And the square of 18 is 324, right? You can add all these values together and then divide it by total number of elements, which is 5 here, right? So you can add all of this. So 4 plus 6 is 10 plus 6 is 16. Then we have 16 plus 9 is 25 plus 4 is 29, right? So this will be 2 plus 2 is 4 and 8 is 12. 12 and 9 is 21 plus 9 is 30 plus 4 is 34, right? 3 plus 3 is 6, 7, 8, 9, 10, 11, right? So this is 1149 by 5. Now you can do the maths to get the final value here, right? So 5 is 2 times is 10, again 2 times is 10, then we have 49, so 9 times is 45.5. Oh, sorry, this is 0.8. Yeah, so 40, right? So this is 0.8. So this is the variance of the data, right? So this is the variance of your data. So mean of this data is 15 and the variance of the data is 229.8, right? So here the idea is basically when you'll be dealing with the data sets, right? You will not see the complete data set and then, you go through each and every individual data points and then finally, move ahead to analyze their data. You're going to analyze the data using mathematical approaches, right? So understanding the mean and variance of the data is one of the most important part here, right? Because if you simply come to me and say that the mean of my data is 15, right? So there could be infinite number of data sets that can have the mean of 15, right? For example, let's say we have our data, which contains the mean of 15, right? I can replicate this data, maybe 15 coming 5 times. The mean of this data is also 15. Mean of this data is also 15, right? I can, create multiple data points, let's say 16, 14, then maybe 14 and 16, right? The mean of this data is also 15, right? So let's say if you want to isolate your data set, right? For the isolation, there are multiple moments that you can calculate on the data so that you can pinpoint, yes, this is the data I am talking about. Right? Because if you calculate the variance of this data set or this data set, this will not be 229.8. It will be some different number. Right? But again, there will be a few data points whose mean is 15 and variance is 229.8. Right? For that, what we do is we go for the third moment in statistics. Right? So before going to the third moment here, you can raise your hands if you know the difference between population and sample. This has been explained in your previous sessions. You can raise your hands if you know this, right? So as I've discussed during your percentile days, when we were discussing the topic of percentile, right? That the population and the sample, these are two different things and they're considered separately in statistics, right? And every formula in statistics is defined differently for a population and for a sample, even if you're working on the same data, right? So the variance that we are talking about here, right? The variance that we are talking about here, this variance is basically the variance of this, the raw variance, right? We can say this is the crude variance, raw form of variance, right? And this is basically defined for population, right? If you want to calculate the same variance on the same data, considering it as a sample, right? So there's a sampling adjustment that needs to be added on the formula for variance, right? And the amount of sampling adjustment that is added is your new formula becomes summation of xi square, right? Summation of xi square, where I will go from 1 to n. This will be divided by n, right? This is the formula for your population. If you subtract 1 in the denominator, this formula becomes the formula for variance for a sample, right? This is the formula for sample variance, right? Every time you're, let's say if someone asks you to calculate the variance, right? This is the formula you are expected to use to get the final output, right? Because the final output will change, right? Because instead of adding everything, right? Let's say the numerator remains same, hence this part remains same, but the denominator changes. Instead of dividing by 5, now we'll be dividing it by 5 minus 1, right? So your new variance becomes this for sample, right? This is 1149. This will be divided by 4. All right. And this number will be higher than 229.8. Right. So if we do the maths here, so 4 times 2 is 8, right? And then we have 34. 4 times 8 is 32, right? And then we have 29. So 7 into 4 is 28, right? One carry, and this becomes 2. All right. So we can roughly represent this as this value. All right. And this is comparatively very high as compared to the formula for mean, right? And this is the sampling adjustment that is being added. And how we landed up on this sampling adjustment is out of the scope of data science, right? Because nobody is going to ask you for the derivation, or nobody is going to ask you for whereabouts about this formula. But yes, you need to use this formula to understand the data you are working on. All right. So this is the sample variance, and this is the actual variance that you are expected to calculate when you are dealing with data sets. All right. Although don't worry, this is the only problem with Excel, right? That you have two different formulas available. If you go on with Python, right, and its modules, for example, let's say in Pandas or in NumPy, right, or SciPy or stats model, right? These are a few libraries that you're going to learn in Python, right? So here, what will happen is the formula is already, this formula is already used, and this is the only formula that is available to calculate the variance. All right. So every time you are calculating variance, you'll be calculating considering your data as a sample, not as a population. All right. So this is how these two are different from each other. All right. Now there is one more catch, and the catch is we'll also introduce this variance. If you see, look at the formula, right, for variance. This is xi square divided by n minus 1, right? This formula of variance has a very large dependency on mean. It has a very large dependency on mean of the data, right? Because if my mean of the data changes, my variance will also change. All right. So what we'll do is we'll again process this formula and make it independent of the mean of the data. Right? We'll make this independent from the mean of the data. And how this can be done? This can be done by shifting of the reference point. Right? So we'll make this independent from mean. Independent. Yeah. We'll make it independent from mean of the data. Right? And how this will be done? This will be done by, right? This will be done by shifting the reference point. Right? We'll simply shift the point of reference. As of now, can anyone tell me what exactly is the point of reference or the reference point in this formula? Can anyone tell me in the chat section, what is the reference point in this formula? All right, so we are getting x, n minus 1, 12, 14, x. All right, so you need to understand that x itself is a variable, how this can be used as a reference. This point itself is a variable, right? And when we talk about variables, it's a variable, right? Which is, it can hold different values at different times based on the data, right? So the reference point, just to give you a more broader idea, right? What is the point from which you're calculating everything? Right, let's say if I ask you, right? Every one of you knows this answer, right? If I ask you, let's say the distance, just another example, right? Let's say the distance between maybe Delhi and Mumbai, let's say is 1000 kilometers, right? If I tell you this statement, right? So if I tell you this statement that the distance between Delhi and Mumbai is 1000 kilometers, from which number are you going to start your calculations? Let's say if you're going via road, right? So from which number are you going to start your calculations? Right? So you're going to start your calculation from zero. From zero. Right? And this zero is the reference point here, because you're taking this point as reference and then calculating your distance, right? Same is done in statistics, right? For every point that I'm mentioning here, let's say, let's get back to our data, right? So the data, it will be more easy to explain on the data itself. I think this was 17 and 18. right? So let's say this is the data we are taking as example, right? So if I ask you, let's say in statistics, we are majorly interested in, since it's part of mathematics, right? Which is why we are always interested in distance, right? In mathematics, everything is all about distance. All right. So let's say this is a number line. I hope everyone knows what is a number line, right? Number line is basically a line on which you can represent any number, be it positive or negative, right? So here, if I take one point as 0, now what I can do is I can plot these points on this number line, right? So let's say this is 12, right? Moving on, next is 14. Another one is also 14. Then we have 17 and 18, right? So these are the number points or points on this number line, right? And what do they represent? Let's say the point which is 12 is at 12 units distance from origin, right? This is also called origin of the data, right? Origin. Or you can also say this is a reference point, right? So here the value of 12 is present at 12 units of distance, right? This 14 is present at 14 units of distance from origin, right? This is at 14 units distance. All right. In the similar way, 17 and 18 are at 17 and 18 units of distance, respectively, from origin. Right. So here, what is done is, since my reference point is origin, right? See, you need to understand one thing. Let's get back to the same example, right? Here, if you look to the statement, right? When I say that the distance between Delhi and Mumbai is 1000 kilometers, right? So what could be done is, let's say you start with your counting with 0, right? Go on with 1, 2, 3, and so on, calculating each kilometer of distance, and you'll end up with 998, 999, and 1000, right? So this is how we calculate distance, right? Or we measure distance, right? So if you see this, finally, what we'll do is to find so this is the starting point, right? This is the starting point and this is the ending point. Now to find the distance, we can simply subtract the end point with the starting point, right? End point and the starting point. Let's say 1000 is my end point, 0 is my starting point, and hence I come to this conclusion that the distance is 1000 kilometers. Agreed? Right? You can simply raise your hands if you agree to this. All right. Now here, since you are able to understand this part, right? So here, let's say, instead of calculating the distance, or let's say taking the starting point as 0, let me take the starting point. Yeah. So let me take the starting point as 500, right? So I'll start calculating 500, 501, 502, and so on up till, let's say, we'll go up till 1499 and 1500, right? So here 500 is my starting point, right? And this 1500 is my ending point. All right. So here again, to calculate the distance, what I'll do is I'll simply subtract the starting point from the end point here, right? And now if I do that, this is 1500 minus 500. So this is 1000. right? So the distance remains same, even if you change the reference point. Let's say instead of starting from 0, I'll start counting from 500, right? That will not change the physical distance between two cities, right? Do you agree to this? I can start counting from any number. I'll simply subtract the lower number or the starting point from the end point to get the final calculation, right? You can simply raise your hands if you're, let's say, if you agree to this, right? So this is exactly what we are going to do in our data when we talk about, let's say, when I'm talking about the shifting of reference point, will shift the reference point itself, right? I'll shift the reference point itself. Now here, if you, let's say, if I, explain you on the same example, let's say here, starting point, how, since starting point is 0 here, right? So instead of using 0 as the starting point, if I want to use 500 as the starting point, what I'll do is I'll simply add 500 to each of these elements or each of these numbers. I'll simply add, let's say, plus 500 to 0, plus 500 to 1, plus 500 to 2, and so on. Simply add 500 to every number, and you'll see that end number becomes 1500 and the first number becomes 500, right? And you can get this data where we were talking about starting the counting from 500 itself, right? Do you agree to this? That if I add 500 to every number, I'll be able to get this data, right? So this is exactly what we are going to do. The calculations are, let's say, when we talk about the calculations, the reference point is taken as 0 so that the calculations are easy, right? They're easy to calculate, right? But we being a human, right? We are always, we always prefer that the reference point should be 0 so that the calculations can be simplified, right? Because the simpler the calculation, the faster will be the results. But this is not the issue with your machine, right? Your machine is a computer, right? It will provide you with the processing power. It has a very good processing power, which is provided by the central processing unit of your system, right? Basically, the chip that you have, right? We're talking about the chip. Let's say if you have Intel chip, or maybe if you're a MacBook user, you'll have the M1, M2, or let's say Intel chips as well, right? If you're a, let's say, if you are an AMD user, you'll have the similar chipset, right? So basically, this is the processing unit where every process takes place in your system. All right. So here, calculations is not an issue for a machine. It can process all the calculations in very less time as compared to human being, right? So which is why what we do here, there are some other challenges for a machine, right? And the challenges are, let's say, higher the number, more power will be used or more resources will be used by your system, right? And when I talk about resources, I'm talking about, I hope everyone knows that there are multiple cores in a CPU, right? Maybe if it's a 8-core processor, it's an octa-core, right? If it's a 4-core processor, it's quad-core, right? In the similar way, excuse me, right? So higher the number, more resources will be used. And these resources are nothing but the number of cores those are available in your CPU, right? If you're going to use more number of cores, the calculations will be faster, but if the numbers are higher, they will be comparatively lower, right? It will consume a lot of time in calculations that you're going to do, especially in machine learning. There are a lot of calculations that goes on behind the scenes, right? You learn that every algorithm in machine learning works differently with a different approach, right? And to implement this approach, your system is going to provide you the computational power, right? And this computational power is nothing but the processing, the amount of processing that is available, right? Apart from CPU, we have GPU enabled systems as well. This GPU is nothing but graphics card that is in your system. Right, the graphics card that you have in your system gives you the power of GPU. And this GPU is faster than CPU. You'll learn about this when you go to your machine learning days, right? The overall idea here is higher the number, more resources will be consumed in any processing, right? And more resources those are consumed. If more resources are consumed, right, you will not be able to work on large data sets, because in machine learning, it's all about what amount of data you're handling, right? And the amount of data that you handle gives you an idea, right? It gives you a better generalization of the prediction that you're going to make, right? You'll understand these things in machine learning. The overall idea here is we try to reduce this number and try to keep this as close as to zero, right? We try to keep the numbers as close as to zero. Right, as close as to zero. All right, so in this process, what happens is this process is basically termed as scaling of data, right? There's the technical term called data scaling or scaling of data, where we scale every, let's say, we scale every data point into such a number that machine can process it with the least amount of memory by consuming least amount of memory, right? So which is why scaling is done, right? And this scaling itself is part of every process or every statistic that you're going to calculate. The scaling is done on top of it, right? So here in the scaling part, the shifting of reference point that we are talking about here, shifting of the reference point that we are talking about here is basically the scaling that we are going to do on our data, right? The min-max scaling we have done, right? If you remember, we have discussed about the topic of normalization, right? Topic of normalization, when we want to scale the data in percentiles, right? You can raise your hands if you can recall it. We discussed this in your percentiles while deciding the value of k in percentiles, right? I'll just give you an overview. This is nothing but x max minus x min. Sorry, this is xi minus x bar divided by x max minus x min, right? This is the formula that is used. This is the formula for normalization. This is also called z-score, right? You're going to learn this in your, again, machine learning days, what exactly is a z-score and how you can scale the data and what is the actual benefit of it, right? So just to give you in very layman's terms, the scaling is done here because we want to shift the origin or shift the reference point, because we want to make the formula for variance independent of mean of the data, right? Which is why what we'll do is we'll simply shift the reference point, right? We'll shift this reference point from 0, or this is also called origin, right, to the mean of the data. We'll shift this origin to mean of the data, right? And this can easily be done. Let me show you. All right, and those who are from the technical background, you must understand this is shifting of the coordinate system, right? I hope everyone from the technical background or those who have studied mathematics, right, post your let's say school days, you must be able to relate with this, right? So here what we'll do is, let me represent those numbers here. 0, then we have 12, right? Then we have 14 two times, right? We have 17, and then I have 18. These are the points, right? And somewhere in the middle, the mean of the data lies, which is 15. This is the mean of the data. Right. So here, what we are going to do is we are going to shift this origin to the mean of the data. Right. So since origin is present at 15 units of distance, this is at 15 units of distance, right? And I want to shift this origin to 15, which means I'll make this 15 as 0. So this is my new data point. How this can be done? I can simply subtract 15 from this. Right? So this becomes my new 0 and 0 becomes minus 15 because I'm going to subtract 15 from every data point. Right? So I'll subtract 15 from 12. This will give me minus 3. This is my new 12. Minus 3 is my new 12 now. Right? Same will be done here. 14 minus 15. This is negative 1. Right? If you subtract 15 from 17, this becomes plus 2. Right? If you subtract 15 from 18, this becomes plus 3. Right? So these are my new data points. New data points. Right? Now, you'll see one thing, that's since I've shifted the origin to the mean of this data, I've shifted this origin. I hope this color is visible, yellow, right? You can raise your hands, put a yes or a no in the chat section. I'll get to know this. Right? So we are shifting this origin to the mean of the data. Hence, my mean becomes 0. The mean of this data becomes 0 now. Right? And since the mean becomes 0, if you're going to subtract anything from 0, or if you're going to add anything on 0, right? So the final output will be not impacted, right? Which is why what we'll do is in the variance itself, when we are calculating variance, right? So when we are calculating variance, I'll simply subtract while adding itself, right? In the formula, this is my original formula, n minus 1 in the denominator, right? My I will go from 1 to n, right? This is my original formula. What I'll do is I'll subtract the mean of this data, and hence this becomes independent of mean now. Because whatever is the mean of the data will remain, will simply subtract the mean of the data from the individual data points, right? And this is how, this is how the data points will be converted, right? And you see one thing, since in statistics we are interested in distances, right? If I talk about, let's say 12, 12 is what? It's present at 12 units of distance from origin, right? So if you see, the distance between points have not changed, right? You can check this manually, right, to understand this part in a better way, right? So the distance between, earlier the distance between 0 and 12 was 12 units, right? And as of now, the distance between 15 and minus 3, right? So negative 15 minus 3, right? So minus of minus is plus, this is 15 plus 3, it's 12 negative, right? So the sign here, negative sign, only tells us about the direction, right? Earlier it was present 12 units to the right of the origin. Now it is present 12 units at the left of the origin, right? Because mean is my new origin now, right? So which is why we are applying this operation on every data set. And now this formula is independent of mean. Whatever the mean of the data is, it will not impact on the calculation of variance. Right? And this value, whatever value that you get out of this, right? You'll get a value. Let's say you'll get a real value. Right? let's say you get a real value. So these real value, it will represent a real value, and this value represents how much spread your data has. This is nothing but the measure of spread, right? More number of unique categories you have in your data, more will be the spread. All right. So this is how variance can be understood. Right. And now, since if you, okay, so I think I missed out square here, right? So if you look at the formula for variance, we are taking square of every term, right? Which is why the variance that we have calculated is very close to the square of the mean of the data, right? So let's say, okay, if you see this value, right? If you see this value, let's say, if you see this value, right? It's almost very near to the square of the mean of the data, right? What is the mean of the data? 15. What is the square of 15? It's 225, right? And this value is very close to this, right? Because it is the square of 15, right? So since this value has been calculated by taking square of every individual data point, right? We are taking the square of every individual data point here. You can see these are squares that we are calculating, right? So since we are calculating the squares, which is why it's very close to the mean of the, it's very close to the square of the mean of the data, right? So since we have taken square, we have to take square root as well, right? To get the values. So what we'll do here is, we'll take the square root of variance, right? The variance that we have calculated, we'll simply take the square root of this, right? And here we get a new statistic called standard deviation, right? This is the new term, standard deviation. And this is again a very important term in statistics, right? Standard deviation basically tells you about how much deviation your data has. Let's say how much deviation the data points have from the mean of the data, from its mean, right? How much deviation your data has from its mean, right? So this is your standard deviation. And this is again, very important part, right? A lot of things are judged based on standard deviation and variance. Yes. So this is how variance can be understood. You can simply raise your hands if you are able to follow up till here, right? Simply drop a yes or a no in the chat section so that I get to know, right? And any doubts are welcome. If you have any doubts, you're free to ask. Right, so the reading materials are already available in your LMS, right? You have to check your LMS. The reading material is already available. All right, so those who are putting no, you have to mention what exactly you're not able to understand, right? And the thing is, these are some, I can understand for people from non-technical background, right? These are a few things that could be a little technical, right? So you need to go through this particular session at least 3 times, right? So that you can relate everything and you can understand things properly, right? Because proper understanding is indeed required. right? So the PDF of reading material is already available in your LMS. Right, so don't worry. Let's say, even if, see, today's session that we are discussing, this is purely the conceptual discussion that is going on, right? And although this discussion is going on so that you get a better perspective of moments in statistics, right? Otherwise, the application of these moments is something that you can directly use, right? But again, let's say, using something without understanding it is not something that is advised in the field of data science, right? If you're using something, you should know what exactly that thing is and how it is working behind the scenes, right? So the best way to do that is, since it is statistics, right, you simply take a sample data and do everything on pen and paper, right? So once you do this, you will be able to understand what exactly is going on and how calculations are done behind the scenes, because we have readily available functions for this, right? In Excel, there's function for everything. In Python, there's functions defined for everything, but you need to understand these concepts in a proper way, right? Because your machine learning interview, when you'll be sitting for the interviews, right? In those interviews, these kind of discussions will take place, right? Maybe your interviewer will ask what is, let's say, variance, or what is a standard deviation, and you should be able to explain him or her in a very clear communication, right? Because these are the basics of uh, machine learning or data science, right? These are basics, and these will form the foundation that is required to study data science. All right. So yes, guys, take maybe 2-3 minutes of break, and then we'll proceed ahead with the discussion of third moment here, which is skewness. All right. So 5 minutes break. We'll resume the session at 10:50 p.m. IST. All right. All right, guys. So let's proceed ahead with the further discussions. Right. So before that, let me address a few doubts here. So practical statistics by for data scientists by O'Reilly Publications. Yes, it is a good book, right? Any book, if you are diving into this field, let me give you this idea that any book from O'Reilly Publications, right? Any book for O'Reilly Publications is really good book, right? This is a good publication house for technical books, or let's say anything that is part of technology, right? For technical, let's say books, right? Anything that is part of technology, you'll find really good books from O'Reilly Publications. You can find these books readily available on Amazon, right? So simply search for any book if you're looking for, right? And you can uh, make a purchase of these books, right? Just for statistics, you can, of course, use the practical statistics, right? Practical statistics for data scientist, right? And this is the first book. The second book that you can use is Think Stats, right? Both of these books are from O'Reilly Publications only. So you can, of course, purchase these books. And additionally, one of you here is asking, is it compulsory to buy books? So it is not compulsory, as I've already mentioned. But yes, I'll suggest you, if you're facing any difficulty in understanding statistics, the best resource you can use is the textbooks, right? These are reference books, right? These are reference books that can be used to understand statistics in a better way, right? Textual form of knowledge or the literature form of knowledge is the best source of learning. All right. So you'll be able to understand all these concepts and topics in a better way. Right. So these are the two reference books that you can follow. Now, moving on, let's proceed our discussions ahead and let's discuss about the third moment. And this third moment is called skewness, right? And this skewness is the measure of, it is the measure of biasedness, right? Bias, if you know, uh, if you look for the morphological meaning of this word, right? Simply look out for this word in any English dictionary, right? You'll find that this basically means some kind of favoritism, right? Or let's say some kind of favoritism, right? So the maybe right. So this favoritism, the measure of this favoritism is basically skewness. All right. So here, again, if you look at the raw formula or the crude form of the formula, crude or let's say raw formula for skewness, skewness is basically represented as skew, right? And the raw form of the formula is summation of xi divided by n, right? Where I will go from 1 to n. So this is the formula for mean. If you take the square of this term, this is variance, right? Instead of taking square, let's say if you take the cube of this term, right? So this becomes skewness. All right. Now here, again, this is for population, right? Now this skewness has dependency of mean as well as the dependency of variance. So we'll remove the dependency of both of it. How this could be done? Let's remove the dependency of mean first, because we have already done that. Right. So the new formula for skewness becomes, I'll simply shift the origin to the mean of the data, right? Hence, xi becomes xi minus mean of this data, and then I'll take the cube of this. All right. Rest of the formula remains same. I equals to 1 to n, right? This is 1, this is not I, and this will be divided by n. Right. So this is the formula for skewness, which is independent of mean. Right. This is independent of mean, but yes, this still has the dependency of the second moment, which is variance. Right. So what we'll do here is we'll remove the dependency of variance as well. Right. And to remove this dependency, what we'll do is we'll perform standardization on this. Right. And what exactly is standardization? Standardization basically is a process right? Standardization, again, you learn this in your machine learning days, right? Yes. Shifting of the reference point to the mean of the data is basically making the individual data points independent of the mean, right? Because we are shifting origin to the mean of the data. All right. So standardization is again another form of data scaling, right? It is another form of data scaling, and how standardization is done is basically if you apply standardization to any data, what will happen is the mean of the resulting data will be 0 and the standard deviation of the resulting data will be 1, right? This is for the resulting data. Right? This is for the resulting data. So basically, if you see, this condition is already satisfied. Right? This condition is already satisfied when we have shifted the origin of the data. Right? Now, this is the condition that needs to be satisfied. Standard deviation of 1 basically means variance of 1, right? Because standard deviation is nothing but the square root of variance, right? If standard deviation has to be 1, your variance has to be 1, right? Because the square of 1 is 1 itself. If you take the square root of 1, it will be 1 again. Right? So what we'll do is we'll divide the complete formula of skewness by the standard deviation. And since we are taking cube of every number in the formula of skewness, we'll divide the skewness with the cube of standard deviation. Right? So basically, this is nothing but I'll only add 1 point here, right? I'll add only 1 point here. And that point is I'll divide it by, I'm already dividing it by total number of elements. I'll also divide it by the cube of standard deviation. Right? If I add this to the formula, this becomes standardized formula. Right? So let's do that. And let me show you the formula. So the new formula for skewness becomes summation of xi minus x bar is the mean of the data, right? Taking cube of every number, and I will go from 1 to n. We'll divide this by n, which is the total number of elements. In addition, we'll also divide this by the cube of standard deviation. Right? This is the formula that is used for population. Right? This is the formula that is used for population. All right. And this formula is basically centered, right? Centered basically means centering the data point, or let's say centering the reference point to the mean of the data, which means the shifting of origin. Once we have applied the shifting of origin, it can be considered as the centered formula, right? Now, we have also divided this by the cube of standard deviation. Hence, this becomes standardized as well. Right? Both of these have been achieved, and this is for population. Only one thing is required on top of this is I have to add the sampling adjustments, right? I'll simply add the sampling adjustments. And once these sampling adjustments are added, this formula will be modified and ready to use for the sample data, right? So how that can be done? It can easily be done. Let's say my new formula for skewness becomes summation of xi minus x bar whole cube 1 and n, right? This will be divided by n, right? And this will be divided by the cube of standard deviation. All right. And the amount of sampling adjustment that will be added to this will be, right? So the amount of sampling adjustment that will be added is this n will be replaced. I'll mention this. This n, please select. Yeah. So this n will be replaced with n divided by n minus 1 multiplied by n minus 2. Right? You have to multiply this with this particular factor. We can remove this now. All right. And this is how the formula is adjusted with sampling adjustments. And this becomes the formula for samples. All right. And this formula is again centered. This is standardized. And this is along with the sampling adjustment. Hence, it becomes the formula for samples. Right. And this is the formula that you're going to use whenever you're expected to calculate skewness of the data. All right. So guys, I've already mentioned that every one of you has to go through this particular session at least 3 times, right? So that you are able to follow each and every point, right? Understanding these terms or these concepts in one single run is practically not possible, especially for the people from the non-technical background, right? Which is why you just have to go through this particular session at least 2 to 3 times to be able to understand everything properly. All right. So, all right. So any figure that you get, you'll of course get a real number as the output from this as well, right? And the output that you'll be getting as a real number, right? Again, it will be a real number, right? And this real number will basically represent the amount of biasedness your data has. Right. So for skewness calculation, you cannot use population formula. Of course, you can use this, right? You can use this, but as I'm already informed, right, we cannot consider our data set as population because there are various types of restrictions that those are imposed if you consider your data as population, right? So for these restrictions not to be imposed, we always consider our data as a sample. Right? So of course you can have examples with the numbers, right? You can take this as a homework, right? How we have applied the data points 14, 14, 17, and 18, right? Simply input these data points here in this formula and try to calculate the output of this, right? You need three things for the calculation of skewness. First, you have to calculate the mean of the data, right? It will be used. Next, you have to calculate the variance of the data. Once you have calculated the variance, from variance, you have to calculate the standard deviation, right? Once you have calculated all of these things, then you can input the values here in this formula and get the output. All right. Let me just give you the idea of this, right? Let's say mean of the data is 15 with us, right? Mean of the data is 15. The variance of the data is 280. I'll just check. Yeah, it's 287.2, right? This is the variance. Right, so this is 287.2. If you take the square root of this value, right? Okay, make sure it is not 229. It's not 229.8, right? This was for the population, right? But we are taking everything as a sample, hence this is for sample, right? So you have to calculate calculate the sample values, right? Next is if we take the right, so let me quickly take the square root of 287.2. Right, so this is 16.94. So this becomes my standard deviation. All right, now I have all of these. The only thing that is required is I'll have to input everything into the formula of skewness, right? And just to give you this idea, n is 5 here, right? 1, 2, 3, 4, 5. All right, so mean of the data is 15. We'll simply input the values here. So the values are, let me take the summation part first. So this is 15. So, okay, so this is 12 minus 15 whole cube plus this will be 14 minus 15 whole cube. Again, 14 minus 15 whole cube. Right, this is 17 minus 15 whole cube. And finally, we have 18 minus 15 whole cube. All right, this will be divided by the first thing is cube of standard deviation, which is 16.94 whole cube. Right, next is the sampling adjustment part, which is n by n minus 1 into n minus 2. Right, so n is 5 here. So this is 5 by 5 minus 1, which is 4. Right, and this is divided by 5 minus 2. All right, so of course these two are in multiplication. It's needless to say. Right, so you can do all the calculations here and you'll get the respective output. Right, so this is how skewness can be calculated on the data. All right, and just assume this is these are just 5 different samples, 5 data points we are taking. Assume if you, and so much calculations are involved here, right? So assume if you're working on a data set that has 1 million rows, right? So just to give you this perspective, 1 million is 1 followed by 6 zeros. Right. So if you are handling this amount of data and doing the calculation of skewness here, right? This is practically impossible for to carry out this calculation on pen and paper, right? Which is why you already have functions defined for it, right? We'll see the functions in Excel, right? Don't worry, we'll see this. All right, so this is how you'll get a skewness. Again, you'll get a real number here, right? You can do the maths and get to this number. So this number basically represents the measure of biasedness. All right, and if you get right, if you get any number, the real number that you're getting here, right? If you're getting any number other than zero, if you're getting anything other than zero, if you're getting anything other than zero, right? Then you have to apply data transformation on this. This is the pre-processing of data for machine learning algorithms, right? Again, you'll learn about the how data transformations are carried out in your machine learning, right? Just I'm giving you this idea that the skewness has to be zero for your machine learning algorithm to get the output, right? Okay, one of you says output is getting zero, how you can multiply, numbers and get zero as the output, because we're not getting zero anywhere. So of course, zero will not be the output, right? All right. So if let's say you're getting anything other than zero, then data transformation has to be carried out. And such a method is to be chosen or selected that will reduce the skewness and bring it as close as to zero. Right? Depending on the use case to use case, there are certain limits of skewness that is acceptable. Right? Otherwise, if you're able to make it to exact zero, that's the best thing that you can do in the data pre-processing, right? Data pre-processing is nothing when you're preparing your data set for machine learning algorithms, right? There are few prerequisites, right? There are few prerequisites of the data or for machine learning algorithms, right? So let me mention this. Okay. So here, there are a few prerequisites for machine learning algorithm. Or you can say simply for machine learning, your data has to meet certain conditions. Some of the condition is, the first is skewness should be zero, right? The second is your data should be normally distributed, normal distribution, right? There are various types of distribution, so your data should be normally distributed. All right. The third thing is everywhere your data, so all the data points has to be in the same range, right? Has to be in the same range of values. It should not be like the height of a person is present from 100 to 200 centimeters, and let's say the age of a person is present from 18 to 40 years, right? This should not happen. Every value should be in the same range. All right, so there are a few requisites again, and right, so let's say it should be free of outliers, etc., etc. Right, so just to give you this idea, to make it independent, or let's say to make the skewness zero, data transformation is applied, right? To convert it into normal distribution, here also data transformation is applied, right? to bring it into the same range, data scaling is applied, right? To make it free from outliers, we use either z-score or the IQR proximity rule, right? So you'll learn about these two methods in machine learning. Data scaling, as I've given you the overview, right? Two types of data scaling we have discussed. First is the standardization and normalization, right? Standardization and normalization. So in standardization, what happens? In standardization, the resulting data has the mean of 0, right? And the variance of 1, or you can say standard deviation of 1. All right. In normalization, what happens is data points are present in the range of 0 to 1, right? Okay, so this will be present from negative infinity to positive infinity, right? I think I missed out. This will be present from negative to positive infinity, right? But all the values will be equally scaled. All right, so okay, one of you here is asking, same range means we can work on height of a person at one point of time and not age, and height and weight at the same time. So the same range of data basically means that your values should be present in within same range, right? How range is calculated? By subtracting minimum value from the maximum value. This is how range is calculated, right? So this has to be same for everyone, right? So for example, let's say when you apply standardization, values get scaled in the range of 0 to 1, right? No matter how large or small the value is, every value will be converted in the range of 0 to 1 after applying standardization, right? After applying normalization, it will be scaled in the range of negative to positive infinity. Right, so standardization is between -1 to +1 or 0 to 1. So standardization is basically from -1 to +1. As I've already informed this negative sign only tells you about direction, right? It only tells you about direction. So when I say that the standard deviation will be 1, this basically means 1 unit towards the right and 1 unit towards the left from the origin of the data. Right? 1 unit to the left, 1 unit to the right and 1 unit to the left. So anything that is present on the right side of the origin is represented as a positive value. Anything that is present on the left side of the origin is considered as a negative value, right? Distance does not changes. The sign only tells you about the direction. So is there a point after carrying out the transformation, skewness will not be 0? Of course, every time you'll face this, right? Because skewness, see, I'll tell you something, right? Skewness is a skewness. It's a concept, right? It's a concept. But when you calculate this skewness on any data, it becomes an observation, right? This is the difference. And see, conceptually, everything is possible, right? Conceptually, everything is possible. But when you apply this, or when you see the applications, there are a lot of restrictions that comes in, or there are a lot of things you'll not be able to achieve, right? To give you this idea, skewness for a real-time data. Real-time data basically means any data you're collecting from the actual interactions or actual transactions, right? It could be any type of data. Let's say the employee data set that we were working on, right? It's a real-time data, although it's just a generated data, right? It is a generated data, but yes, if it belongs to some organization, it will be a real-time data because it represents real values, right? Real employees, their real salaries, their real age, their real department, right? So this is real-time data. And for real-time data, skewness can never be zero. You will not be able to achieve this. You will never be able to achieve the skewness of zero. So what do we do in that case is when we apply data transformation, there are various methods, right? N number of methods to apply data transformation. The idea is when I'm not able to achieve the skewness of zero, what I'll do is I'll try to achieve the skewness as close as to zero, right? As close as to zero. For example, let's say initially the skewness is, let's say initially before transformation, let's say before transformation, right? Before transformation, if the skewness of the data is 10, right? Just an example. If the skewness of the data is 10 and after transformation, if I'm able to get the skewness of the data as 1, right? So 1 is better than 10. Because if we are not able to get something, we try to achieve as closest number as possible. Right? Because the closer we are to zero, we are basically making better impact, or we are trying to fulfill the prerequisites of machine learning. Right? You can understand it in this way. Remember your college days. Right? Remember your college days. Let's say you have your semester exam, right? And everyone wants to achieve 100% result. Maybe, CPI 10 on 10, right? But practically, no one is able to achieve this 100%, right? So what you do is you work hard so that you can get as close as to 100%. Maybe some are able to, make it up till 80. Some of them are able to make it up till 90. Some of them are able to make it up to 95 and so on, right? So the more closer you are to what you want to achieve, the better uh, the better you are a fit for the environment, right? So let's say if it's college days and your semester exams are going on, so the more closer you are to 100%, the better is your result, right? The same thing happens on transformation, right? If earlier the skewness is 10, and if you are able to reduce it up till 1, so skewness of 1 is better than having the skewness of 10. All right. And what methods are used for data transformation? You learn this in machine learning, right? I'm just giving you where exactly skewness is used when you're working with the data. All right. So let's get back to our original discussion. Right. Let's get back to our original discussion here. And we are working on the formula for skewness. Right. So yes, there's the formula for skewness that will be used. All right. So zero skewness basically means that data shouldn't be biased. Zero skewness basically means that your data is not biased, right? Your data is not biased. Skewness of zero basically means your data is not biased. All right. Now, moving on to the final moment that we have is the fourth moment called the kurtosis of the data. Kurtosis is basically the measure of peakedness. Right. Peakedness is nothing but, let's say, how high or low the curve is. Let's say this is your data, right? So this peak of the curve, whether it's higher or lower, let's say if it's lower, it will be like this, right? And if it is higher, it will be like this, right? This is high, this is low, right? This is low, and finally we have this. This is normal, right? So again, the kurtosis gives you this idea how high or low this peak of the curve is. All right. Now, to look at the formula, again, like how we have, since this is the fourth moment, kurtosis is represented as kurt, right? And if you see the raw form of the formula, this is, since this is the fourth moment, right? Which is why I will simply take the fourth power of every number and divide it by the total number of elements. This is the raw form or crude form of the formula, right? Now, moving on, talking about, let's say, again, this formula is dependent on mean, right? It is dependent on variance, all right? And sampling adjustment is still not added. So we'll first make it independent of mean, right? Which means we'll center this formula to get a centered formula, right? And again, this could be converted like this. It will be summation of I equals to 1 to n, and this will be xi minus the mean of the data, taking the fourth power and dividing it by n. This is centered formula for kurtosis, right? Now we have made it independent of mean, right? Let's make it independent of the variance, right? So since again here we are taking the fourth power of this, what we'll do is the new formula for kurtosis will make it standardized. Right? Okay, what is the meaning of centered formula? Centered formula basically means when you're making the formula independent of mean, it's called the centered formula, right? How will you differentiate between different formulas that you have, right? By the time I give you the final formula, you'll have 5 formulas for kurtosis. How will you differentiate, right? So this is how the differentiation is done. This is centered, right? This is the raw form or the crude form of the formula. Now we are going to write the standardized form of the formula. Again, I will go from 1 to n, right? Xi minus mean of the data, taking the fourth power, dividing it by n, and finally dividing it by the fourth power of standard deviation. Right? So this is already centered, and now this has become standardized as well. Right? But still, it is for the population data. This is for the population data. Right? So we'll apply a sampling adjustment to this to get the formula for kurtosis that we'll use for samples, right? So sampling adjustment will be added on top of this. All right, sampling adjustment will be added on top of it, and the new formula becomes, I'll write the older formula first. So my kurtosis is, let's say this is summation of, right? This is summation of xi minus x bar, which is the mean of the data, taking the fourth power. I will go from 1 to n, right? And we'll divide this by the fourth power of standard deviation. Right? Now let's add the terms for sampling adjustment. So since we are taking the fourth power, which is why here a little more sampling adjustment needs to be added, right? So let's add that. So this will be multiplied with basically your n will be replaced with n into n plus 1 divided by, this is n minus 1, n minus 2 multiplied by n minus 3. All right. And finally, we'll subtract this with 3 times of n minus 1 whole square and divided by n minus 2 and n minus 3. Right. So this is your final formula for kurtosis. This formula is centered, right? This is centered. This is standardized, right? Right. This is centered, standardized, and this is for samples. Right. And this is the formula that is being used wherever you want to calculate the kurtosis. Right. This is the formula that will be used. All right. So having an example with a number remains homework for you, right? Apply the same data that we had been discussing, right? Do it on pen and paper. You'll have better understanding of this, right? It is just replacing the, or just putting down the numbers and calculating the output, right? Otherwise, anyhow, I'm going to show you this in the Excel as well, right? I'll just give you the implementation of this in tomorrow's session, right? And along with this, let's say we'll apply moments in Excel, right? In tomorrow's session, we'll also discuss about VLOOKUP, or basically lookup functions, right? And finally, we'll discuss about covariance and correlation, right? These are the topics for tomorrow's session. Yes, I can understand these are a little tricky topics to understand, right? So which is why I've already advised you need to go through this at least 2-3 times, because you have to understand this to be able to understand machine learning, right? Without understanding this, you'll face difficulties in your machine learning days, right? So basically, no way out. You have to learn, and you can follow the reference books. Right. So you can follow reference books if you're able to, if you're finding it difficult. Otherwise, there are chances that when we discuss about the implementation of this, right, you can easily find reference books. I've already told you, you can find the reference books on Amazon. I gave you the name of the books as well, right? It's Practical Statistics for Data Scientists or Think Stats. These are the 2 books that you can follow, right? You'll easily find these books on Amazon. All right. So yes, guys, with this, we'll be wrapping up the session for today. All right. And uh, let's say I'll wait for 5 more minutes. If any one of you have any doubts, you're free to ask. Otherwise, those who are leaving the session, I wish every one of you a good night. I'll see you tomorrow. Right. So if any one of you have any doubts, you're free to ask. Else we'll wrap up the session soon. Right. The name of the book is already, I think you should, right? The name of the book is already provided. You should be a little more focused during your sessions. Right? These are the name of the books. Right? So you can follow these books for reference. The name of the book is Practical Statistics for Data Scientists and Think Stats. All right. So the assignment given last week, if you're not able to do any of it, right, the tax on the amount, I think this is, you should be able to do it, right? I think because we have already discussed that part in the live session itself, right? So let me see on percentage. Yeah. So this is the tax part. You should be able to calculate because we have seen the practical implementation of this in your live session. All right. So if you're not able to calculate the total price, you should go through the session where we have discussed this particular part. All right. So everything, like all the resources, everything is available with you. Every one of you is expected to work hard if you really want to transition your career into data science. All right. I'll share the GitHub link. So in normalization, mean is 0. In normalization, mean is not 0. Right? In standardization, mean is 0. All right. So guys, if any one of you is not able to find uh, the PDFs, those are available in your LMS, you need to get in touch with the career coach team, right? Get in touch with them and tell them about your problem, right? They'll be able to help you on it, right? Because it's available for everyone. So presuming it is available for you as well, right? If you're not able to see it, you're advised to get in touch with the career coach team, get it resolved as early as possible. Guys, you have to understand that the GitHub link that I've shared with you is it only contains the resources we are discussing on live session and the questions related to it, right? The PDF of the notes is not available on GitHub link, right? It is available in your LMS itself. Right. So what do you understand by standardization and normalization in simple terms? So standardization is basically a process that you apply to reduce your mean to 0 and standard deviation to 1. Right. And normalization is a process where you bring the range of values in the same range. Right. Normalization in simple terms can be said as generalization. Right. There are normalization associated with a lot of terms here. Normalization is used differently when you're talking of different perspective, right? For example, it's a normalization when you're talking in terms of data sets or in terms of machine learning, it means different, but normalization in terms of SQL is different, right? All right, guys. So let me share the GitHub link and then we'll wrap up with the session for today. Okay, so in the chat section, I'm sharing the GitHub link with everyone, right? This is where your Excel assignments are available, right? The solutions I'll upload it on Monday. All right. So yes, guys, with this, we are wrapping up the session for today. I thank you everyone for joining the session. And I wish every one of you a good night. I'll see you tomorrow at the same time.